So okay, we want to send the traffic from this busy box on the master node to the Nginx pod on the worker node. The Nginx pod has this IP address. Busy box has this IP address. They are in different subnet. So for the IP packet in the layer 3 to work, this guy needed to know the route IP to this network. So let's log into the BusyBox pod. We have the pod. Log into the BusyBox pod. Check the IP route. Okay. So we have a default route, and to use this gateway IP. Okay. So who has this IP address? And what is the ARP, the MAC address for this IP? Okay, so it has this MAC address. Remember, this is in the container network namespace. So that is the view from the container network namespace. Now let's get into the Linux default root network namespace. Exit, and let's see who had this IP address. Can you guess? Based on this diagram. Okay, let's show it. IP show. Who has that gateway IP address? This guy. The container network bridge interface has that gateway IP. So this is all happen automatically, like everything is set up automatically. It's not a manual configuration. And so this is a gateway IP, and now we know that when the packet originated from this busy box, it will use this as the default gateway and the interface. Yes. And if you see the MAC address here also matches the ARP entry in the container network namespace here, the MAC address. Okay. So now we know why the packet here, it will go through here and here. So from here, how does it know to get it to the VXLAN final interface? Again, in the root network namespace, we needed to check the route to the Nginx, to this guy. Let's check the route for this destination IP address. Okay. Get it to this destination IP address. Use this gateway IP. It's a network address, looks like, through this interface, the VXLAN final interface. And but in order to get it here, get it to this IP, we needed to know the MAC address for this address. Let's see what's the MAC for this address. MAC address. Okay, so this is a MAC address for this guy. And by the way, the VX9 Flannel interface, it itself is a bridge in the sense that when the packet get it to this interface, it will check for the destination MAC address, which port it should forward to. So let's see, FTP show dev nano.1. Oops. Okay. So we have a FTP entry here to get it to this destination MAC address. Use this destination host. Remember, this is a VXLAN Flannel interface, so it will do the actually do the packet encapsulation for the inner packet for the inner packet originated from here. But how this interface, how this guy knows what outer source MAC and outer destination MAC address to use to encapsulate the inner packet. So to get into that detail, it's actually will be helpful to look at how it works in the Linux kernel. But this time I want to I want to explain how it works in the kernel driver. But I can show you from the user space. We can the same thing. We can check in the root network namespace. We can check what's the route to get it to this destination IP. What local interface we should use. Okay, route get. Okay, so we have a route entry here, local route entry here. To get it to this destination IP, we need to use this interface and use the source IP of this. And did you notice? Do you notice? This is the master node IP. This is a workload IP. And we can in the kubernetes world, let's describe the node. So the workload, let's see. So we have an annotation here. The VTAP MAC, this MAC address, VXLAN backend. This is the workload. Let's see the master node. The annotation here, the VTAP MAC with this guy, VXLAN, public IP. Let's see IP linked list. The VX Fernando VX9 interface 69E1. It is the same in the, that is a VTAP MAC here that that Kubernetes knows about. Yeah. So basically, what I'm showing here is to tell you that for this guy to know what the yeah